In this problem, we are asked to use radical notation to rewrite the following expressions and then to simplify them if possible. So what we have to do is look at what rational exponents mean. So if I have a raised to the fractional exponent m divided by n, it can be written two different ways. It can be written as the nth root of a raised to the mth power, or it can be written as the nth root of a that is all raised to the mth power. They're totally equivalent. So when we have a raised to a fractional exponent, notice the denominator of the fraction becomes the index, and the numerator becomes the power to which I raise my variable. Does it work the same over here? Yes, n is the index and m is what I raise to the power. Now these two forms are totally equivalent, and if I have a variable expression, I'm going to use this one here because it's more compact than the other version. But if it's a number, so if it's numerical, I'm going to use this expression here because it makes the arithmetic so much easier. So let's look at our first example. I have 81 raised to the half power. I'm going to use the second version. And so what does this mean? It means which root of 81. Remember, the denominator becomes the index, and the numerator is the power to which I raise my answer. So do we ever write the 2 under square root? No. Do we ever write the 1 when raising to the power? No. So this can just be written as the square root of 81. So square roots, these are the perfect squares you should be familiar with. Is 81 on there? Yes. So what's the square root of 81? 9. So there is my answer for the first problem. Now let's look at our second example. This one's going to be a little bit more complicated. So I have 25 under my radical. What is my index? The index is the denominator, 2, and then when I've taken that square root, I'm going to have to raise it all to the third power. So, do we ever write the 2 as an index? No, so I could rewrite this as the square root of 25 all cubed. And what is the square root of 25? Here's 25, it's a perfect square. What's the square root? 5. So it's 5 cubed, and what is 5 cubed? 5 times 5 times 5 is 125. So what I want to show you is why I recommended using this one for a number. If I decided to write it this way, I would have written it as the square root of 25 cubed. And it's possible to work that problem out, but do you really want to figure out what 25 cubed is and then take the square root? I don't think so. So if you use this second version, your numbers are a lot smaller, a lot easier to handle. So now let's take a look at our last example. The first thing is to convert it. So I'm going to have a radical with negative 64 underneath it. What is the index? It comes from the denominator, so this is the cube root. And when I've done that cube root, I'm going to raise it to the numerator to the second power. Now be careful, I'm taking a cube root. Remember, the square root of a negative number is not a real number, but the cube root of a negative number is a real number, and it has to be a negative number, because a negative times a negative times a negative will give you a negative number. So now I need to look at the cube root of 64. Be careful with 64 Notice 64 is a perfect square, but it is also a perfect cube. So we're not taking the square root, we're taking the cube root. So what is the cube root of 64? 4. So the cube root of negative 64 is negative 4, and then I'm going to square the answer. Double check this. If you multiply negative 4 times negative 4, you get positive 16. 16 times negative 4 is negative 64. So now the last thing I have to do is negative 4 squared is negative 4 times negative 4 is positive 16. So that is our answer.